Welcome. This is one of those topics where the documentation explains what it does, but doesn't tell you when to use it. We're going to fix that. Chrono is the standard library's time facility, clocks, durations, and time points. Format is the modern way to produce readable output without the verbosity of stream chains. Together, they let you measure time correctly and present results cleanly. Let's get into it.
The first decision:
which clock to use. Steady clock is monotonic. It never jumps backward, even if the system time is adjusted. Use it for elapsed time measurement, benchmarks, retries, and timeouts. System clock tracks real-world time and can be formatted into calendar dates. Use it for timestamps meant for humans. In this example, we capture start and end from steady clock, then compute the elapsed duration in milliseconds using duration cast. Duration cast converts between duration types, here from the clock's native precision down to milliseconds. Steady clock is the default. Reach for system clock only when you need calendar time.
Chrono literals make durations readable.
250 milliseconds is written as 250 milliseconds. 5 seconds is 5 seconds. No more magic numbers representing time in ambiguous units. You enable them with using namespace std chrono literals. Then you can compare durations directly. If elapsed is greater than 2 seconds, retry. The compiler enforces type safety. You can't accidentally compare milliseconds to an integer without a conversion. Literals remove the guesswork that comes with raw integers. When you see 250 milliseconds in code, there's no question about the unit. Standard format replaces the verbose stream insertion chains you've been writing. Instead of std cout, shift, value, shift, string, shift, you write std format with a format string and arguments. The curly braces are placeholders. The arguments fill them in order. For direct output, std print writes to standard out without creating an intermediate string. Both scale better than stream chains once formatting becomes structured. Format strings support width, alignment, precision, and type specifiers. Everything you need for clean output in one readable line.
A practical benchmark function.
Benchmark sort takes a vector by value, captures the start time from steady clock, sorts the vector with ranges sort, captures the end time, computes the duration in milliseconds, and prints the result with std print. This is the pattern you'll use for any quick timing measurement. Capture before, do work, capture after, compute the difference, format the output. Steady clock ensures the measurement isn't affected by system time changes. Duration cast ensures the output is in a human-readable unit. A stopwatch class that accumulates time across multiple start-stop cycles. Start captures the current time point. Stop adds the elapsed time since start to the running total. Reset zeros everything. Elapsed ms returns the accumulated duration in milliseconds. The key insight: all internal state uses chronotypes, time points, and durations. No raw integers. This means the compiler catches unit mistakes at compile time. You can't accidentally add milliseconds to microseconds without an explicit conversion. This is where chronotypes become practical instead of abstract. System clock time points can be formatted directly using format specifiers that follow the STBG conventions. Here we capture the current system clock time, then format it as year, month, day, hour, minute. The %y gives the 4-digit year, %m gives the 2-digit month. %d gives the day. %h and %m give hours and minutes in 24-hour format. This produces output like 2026-04-2314:30. Use system clock for any timestamp meant for people, log entries, file names, user-facing displays. Steady clock can't be formatted this way because it has no relationship to calendar time. Time point arithmetic is straightforward once you understand the two types. A time point represents when, a specific moment in time. A duration represents how long, a span of time. You can add a duration to a time point to get a new time point. Deadline equals now plus 250 milliseconds. You can subtract two time points to get a duration. Elapsed equals end minus start. You can compare time points. If now is past the deadline, retry. Keep these roles separate. Time points answer when. Durations answer how long. Most chrono code becomes cleaner once you stop mixing the two. 4 common mistakes with chrono and formatting. First, using system clock for elapsed time measurement. System clock can jump forward or backward when the system time is adjusted. Your benchmark suddenly shows negative time. Use steady clock for timing. Second, converting to milliseconds too early. If you cast to milliseconds at the start, you lose microsecond and nanosecond precision that might matter. Keep the native precision until the final output. Third, mixing raw integers and chronotypes. If your timeout API takes an int representing milliseconds, you lose type safety. Take a chrono duration instead. Fourth, formatting timestamps from the wrong clock. Steady clock has no calendar meaning. You can't format it as a date. A side-by-side comparison. Steady clock, monotonic, never jumps backward. Use it for benchmarks, timeouts, and retries. It's the default choice for measuring elapsed time. System clock tracks real-world time. Use it for calendar formatting, logging timestamps, and any output meant for humans. But be aware, system clock may adjust due to NTP synchronization or daylight saving changes. If you're measuring how long something took, use steady clock. If you're recording when something happened, use system clock. Pick the clock that matches the question. 3 exercises. First, measure the time taken by a parser or sort routine using steady clock and duration cast. Print the result with STD format. Second, find a function in your code that uses a chain of STD cout insertions and replace it with a single STD format call. Compare the readability. Third, write a small helper function that takes a callable, runs it, measures the elapsed time, and logs the result in milliseconds. Use it to time several operations and compare. Here's the key takeaway. Steady clock for timing. Monotonic, reliable, won't jump. System clock for timestamps. Calendar aware, human readable. Steed format for output. Clean, type safe, scales better than stream chains. No more raw integers for durations. No more cout shift chains for formatting. The Chrono library gives you type safety. The format library gives you readability. Use both. For next topics, continue with modules and coroutines for the newest C++ language features. Then, build systems and tooling for CMake, package management, and project structure. You now have the time and formatting toolkit. Thank you.